Mr. Raghavendra Mirji. He has been associated with Godrej and Boyce for the last 2 decades and is presently positioned as Senior Vice President and Business Head for Electrical and Electronic Division at Godrej and Boyce Manufacturing Co. Limited. He has worked in different businesses and functions and has been instrumental in scaling up the T&D business for Godrej. Today, Mr. Mirji will talk about smart grid solutions, evolving trends in the grid modernization. So, delegates, let's welcome Mr. Raghavendra Mirji.
Thank you,
Yes.
Megha, once again for giving that lovely introduction. Very pleased to be associated with EPR and happy to be with this, webinar Asian Boys, which is electrical and electronics, and the T&D vertical is one of my business portfolio. Coming to straight away to the topic, the smart grid. So, Megha, you mentioned in the reference to the smart grid. So 2-3 elements. One is the trends, obviously you mentioned, then hence we'll be compelled to discuss about some of the things that is important in the smart grid space, the need or rather the complications and requirements. And the other part, interestingly, I have put is the reality check. And I think that's where the larger discussions and the debate probably needs to be done, where technical data may not be required. And then it requires more of an intellectual discussions and sharing of ideas, and I'm prepared to do this into different buckets. See, India power sector is actually into a very, very exciting days, I can say. From what it used to be 2 decades before, maybe even 10 years before, and the way it has progressed in the last decade, especially in the last 4 or 5 years, definitely very, very exciting days ahead. So with 17,500 circuit kilometers of lines announced in the next 2-3 years, the 80,000 MVA capacity of transformation to be adopted, and a very big budget of about more than 1 lakh provided in the national infrastructure pipeline. The government of India, has really put a very transformational journey in the power sector, mainly to secure adaptive, sustainable, to achieve the secure, then the sustainable and diligently enabled ecosystem that really provides reliable, quality energy for all the active participants and the stakeholders, including the industry, the agriculture sectors, which is actually the growth drivers today in order to achieve 5 billion economy, by 2025 or maybe 2030 to an extent. So having said that, smart grid is one such element which has added to the grocery of smart. We have heard about smartphones, and then slowly we also heard about smart cities, and then I don't think many people understand and correlate the IT enabled system that we see on a day-to-day basis in the smartphone, that what is in the card when we talk about smart cities and smart grid. So I always tell people that smart grid is not necessarily an automation of a substation. That's a very, very low level definition, then I would say. And then many people may feel that having a SCADA system and then a manless substation is an achievement of a final smart grid goal. The smart grid is really an integration right from generation to the user end, which I, in the next 2-3 slides, would like to highlight so that, the understanding of the smart grid is clear to many of the people. Now, just you go back to the previous slide and just tell me. So where is the need comes for such things? When we talk about integration, when we talk about, it's nothing but a smooth flow of the electricity from generation to the consumers, and it's a two-way communication that normally defines as it is smart. So it's not just a offering that one can give you and the consumers have to take it or leave it. So it's a two-way communication which smart is actually bringing in. So it talks about resilience in the system. It has to deliver more reliable power and the efficient power that we never seen before. So India struggled with the connectivity issues earlier, and having connected all the villages, I would say, in the last decade, we covered last mile connectivity of, in most of the states and achieved connectivity almost 100%. The next level challenge is how do we provide 24/7, power to everybody. Now there comes the reliability, the efficiency part. That's the reason I say the need comes from these particular things. Then we are also in an era of talking about sustainability, in a big way, saving Mother Earth. We are talking about greener power, already. And India has put up a very bold ambition of achieving 500 megawatt of gigawatt of the renewables by 2030. That really states the ambition of government as far as green energy is concerned. So when such alternate energies are produced, the integration is also very important, where the balancing of the grid things becomes very more important. The outage because of any imbalance issues, instability issues needs to be curtailed, and that frequency and duration has to be reduced. That also one of the need. And of course, the storm impacts today is also seen, and then controlling of those acts becomes very necessity. Real-time data-driven action plan is what is really calls for if we have to really cut down on the duration and the frequency of the outage, because it has to be simultaneous or instant action. So we can see today in an app era, we can get the information faster. Similarly, in the electricity also, everything should be taken care, and there should not be really lapse of time in fixing the issues. That's the expectation. The biggest thing, Mega, is always the balancing of the supply demand. In today's modern era, the more urbanization, the more electrification has really driven the consumption, though we are still lacking per capita consumption, but still it is going far more than what it used to be earlier. As a result, we see the peak power going up in a particular period. Then that becomes a big headache for the regulators, for the utilities to balance the demand and the supply. So it is more difficult because of the lack of data, the lack of the speed in getting the information on the demand side, mapping it accurately. Data-driven decisions is what is actually making us take more time, or failing in this area in a big way. So in Mumbai, we might not really see those issues. Largely, it is protected through an islanded system. But in the other cities and other things, it is very, very evident. That's the reason I'm bringing this point. Of course, the major issues where both the DISCOMs or the power utilities are facing is the losses. Though India has progressed well in curtailing both the transmission losses as well as the AT&C losses in a big way in the last decade through various initiatives, but yet the losses is one big inefficiency in the system that we'll have to deal with. So bundling all these things creates the need for the smart grid. So I'm just trying to put it the comparison, what is smart versus the existing in terms of the grid. So one is electromechanical, then we see a lot of electromechanical, be it equipments, instruments, versus in the smart grid we go for a digital era, including the Wi-Fi connections where transmission of data becomes very easier. As I said earlier, it was a one-way communication. In digital era or a smart grid, we see a two-way communication. One side, we had a centralized generation. Today, customer is also a producer and also a consumer himself. So he will install the rooftops on his houses. And we also have seen a distributed generation through renewables coming up largely, and then the dynamics is quite different. Yes, the sensors are the core in the smart grid, where it can sense and send data, and monitoring becomes self-monitoring rather than manually or people oriented. The restoration, as I talked about, is a self-healing. The diagnostics, that tool that we can install, the sensor that we can install, the restoration becomes quite easier in that sense. And of course, the blackouts, failures are all can be controlled through a very adaptive protection systems. And the one that I talked about in Mumbai, the islanding system, where more or less we can achieve 24/7 uninterrupted power. So the choice today is also very, very important, where customer expectations changing, customers desire changing, and they say, give me a choice of choosing the utility or a DISCOM that I want to work with, rather than we had a very few choice in the earlier. So these are the need that I talked about, and then a slight changes that I just wanted to bring in. What are the existing grid and what is the smart grid that we are talking about? Yeah, next. So this is a very typical the diagram that depicts the overall ecosystem of the smart grid. What are we talking about when I say smart grid? I did mention that it is not a substation which is automated. It is not a substation which is manless, that we are calling a smart grid. When we say smart grid, it should be seen in ecosystem. Otherwise, the end results are not achieved. Now, if you see here, the control center today, it could be the state level load dispatch centers at a state level, at a regional level, RLDC, or it may be at a national level. So this is equipped with, the very good ecosystem in terms of assessing the true demand that actually can be mapped, the true climate, the true quality of the power that is actually being distributed there, and then can communicate to the, through a we call it as these are all GPS systems, GPS satellite. So today we are installing GPS satellites in every substation. Slowly it is happening. But okay, so through the GPS satellite, the communication is established, with the users as well as with the generating utilities. So essentially here we are building an ecosystem of informed and empowered, kind of a system. So here we are talking about multiple generating sources, leave alone the conventional source of a thermal power or a nuclear power earlier. And today we have a distributed generations, as I talked about. It could be the solar parks, it could be the rooftops that is coming up, it could be the biomass, generating system that one can have. The battery storage system coupled with the solar park, which can even cater to the nighttime requirements. So there are multiple generating sources which today will put the power into the grid. Consumers, they need to install a smart meter, because without which the ecosystem is not completed. The smart meter senses the demand pattern of a user. It communicates again through a GPS to the control center. They are, in a real time almost able to understand and assess the demand side, able to understand what is the health of the electricity in terms of the frequency, in terms of the voltage, current, the other electrical parameters that are important to balance. So this entire ecosystem is what is important to achieve the overall benefits for the smart grid ecosystem, and not the standalone, whether we are talking about only at the generating side or whether it is at the transmission side or maybe only at the distribution side. So I'm talking about it's a combination of everything. So this is one diagram that actually depicts. I will not get into the technicalities because that's not the idea today to explain the smart grid in technically. So I would leave it, the explanation at this point of time. Yeah, just move to the next level. So then there are two basic things that we need to really talk about. One is transmission side solutions, what needs to be done, and on the demand side solution, what needs to be done. So on the transmission side, to ensure the smart grid works efficiently, then we need to really have a WMS, installed, which is measuring, things on a real time. And there are PMUs which will also help in getting the data. Then there are advanced analytics which are fed into the system, which will help the control center to derive a complete demand supply pattern and then communicate to the generating sources that whether they need to fasten the or increase the generation, or they need to control the generation. So that is one area. Then we call it as a dynamic compensation. So with the integration of RE, there is going to be an imbalance, or the stability of the grid happens because of the reactive power getting into the picture, and then managing that in a shorter period, and then bringing the grid into a stability mode is very important. So there are technologies which are installed which will address these issues, and hence it will compensate the reactive power issue and then give the stability to the grid. Then of course the third element which is also important is an automation, where advanced ID equipments, protection systems, protection monitoring systems, including even the measuring, the testing equipments like DCRM, which is very, very important. And I'm very happy to say today most of the utilities are adopting the DCRM systems to check losses and other things before the equipments are put to use. So those things are part of the substation automation also, and of course digital substations where everything is measured and then data is captured to understand the faults, to understand the losses, to understand equipment failures well in advance, so that the maintenance and the breakdown issues can be really addressed. The next is the strong connectivity. So this requires a large the balancing of the network, and of course the transfer of power to the longer distances, which is still today, though we call it as a distributed generation, still even the renewable power has, it's in pockets. Rajasthan is largely producing the renewable energy. The Gujarat is producing the renewable energy in a big way. The solar parks are concentrated in these 4 or 5 states, and hence the corridors that needs to be made, the transmission has to be done again from a long distances. So that connectivity is also important thing on the giving solutions to the transmission side. On the demand side, so as I said, I'm taking it in an ecosystem, and this has to be seen in a holistic approach, as I said, because it's not just related to only the generation or substations as transmission, part of the transmission, but it is also important at the demand side. As I said, unless until we connect consumers with the smart meters and then give him complete empowerment in terms of he knowing how much consumption he is actually incurring through a different appliances. So there are things that he can exactly pinpoint how much his washing machine is consuming the power, how much his fridge is consuming the power. Then he also can decide how to improve his power consumption in a big way. Then today even the multiple level of tariff is also playing a role, where the evening tariffs are different, the morning tariffs are different, the peak tariffs are different. Then the consumer, if he is informed with the smart meter, and he can even measure that where he is making power, when he is making more power consumption. So an informed decision also will empower a customer to decide on the way he wants to really consume the power. So I think that's a different level of empowerment that we can see through this smart grid solution. So advanced metering infrastructure, we call it as an EMI, becomes a very, very important parameter in the entire ecosystem. Next comes the outage management system. So outage may become inevitable in some cases. It can happen because of the demand supply issue. It can happen because of the reactive power issue, maybe the stability issue because of the RE power injecting into the systems, or it could be any other failures. Islanding, I talked about one way of managing things. There are many things how we can really design a system to manage this outage, so that the reaction time and the duration of the outages comes down, which is beneficial to the customers. The third thing is peak load management. So as I said, consumers today, the consumption pattern is very erratic. We cannot really dictate how a consumer can use his appliances, or how a factory can really ramp up their productions, their usage and other things. So how do we really balance and address the peak load, the management? So there are many solutions, of course, as we move across in the next level of discussions, so we can discuss on that. The next thing is the power quality. We are talking about the frequency issues. We are talking about the voltage drop. We are talking about the harmonics. Now, how do we really improve the quality of the electricity that we are consuming becomes another aspect to address as part of the smart grid. Of course, then today EVs are actually picking up. Government is pushing. There are incentives for owning up electric vehicles, and then with this new element coming in, then how do we really address the entire EV sections more efficiently without again getting into a problem? So that is another part of the smart grid, the ecosystem, that is also on the demand side. These are all coming from the demand side, and we are seeing where the conventional lines are not reachable. We are also using microgrids. We are using distributed solar generations in tribal areas, in J&K, also in some areas where the things cannot do. Now, how do we put those also back into the network of smart grid and manage? So I talked about the transmission side solutions, and these are the things that we need to really address and get the solutions on the demand side. So now I'm coming to the trends that you talked about. There are technologies for the smart grid that we can think about it. So yes, as I talked about advanced meter infrastructure, it's a smart meter. So this provides the time monitoring, measurement, and also an ability to transfer the data. It also has a feature of studying the load pattern and then gives details to the management. It can also give you the real-time pricing and customer can decide. I also talked about peak load management through an algorithm-based real-time load shedding system. So that is a trend which is again can be used in the smart grid, and it will help in reducing the tripping through a load curtailment, which is also important aspect of the entire load management. Coming to the power quality management, we have systems which can reduce the voltage flickering. We have system which can improve the distorted harmonics that I talked about, and hence it will reduce the losses. So there are technology to address these issues, which are also kind of a trend as part of the smart grid technology. Next. So outage management, as I mentioned, in outage management, what is important is scheduling and unscheduling the outages. How frequently we can change this, how efficiently we can manage this, and hence how overall we can improve the system for the availability is concerned. So that technology is available to manage the outage management. Microgrid I talked about, distributed generation I talked about, and I will not really spend more time on that. So the next level, the technology is the phasor measurement unit. Now today, as I mentioned, in most of the substations, the utilities are insisting on installing the PMUs. It measures and analyzes the real-time power transmission parameters, and it will also understand us to get the proper behavior of the entire power system so that we can control it better and we can solve the issues in a better way. So PMU is definitely the trend in which things are moving in the right direction there. Another thing is green energy corridor. So rather than we complicating the issues of putting everything into the grid, then the other solution also came that why can't we have a separate energy corridor which is also serve the purpose and solve many of the problems. So we have seen announcement by the government in many green energy corridors are announced. So the infra is being discussed. The next level, the technology innovation, or rather the new technologies are the SVC and STATCOMs. So these are very important to balance the reactive component of the increased load in the system. So hence these technologies are also increasingly used today, which is a trend. On the dynamic compensation, facilitation for integration, maintaining grid parameters, introduction of, as I mentioned, hybrid kind of a STATCOMs, if not the straight one, and static VAR compensators. These are the technologies which are used to improve the stability of the grid and also to ensure the assessment of the problem in the grid area. So these are the latest trends as far as the smart grids are concerned. Next. So implementation of storage battery and HVDC, India is lagging very much. So storage battery is hardly, so if I can give you the number, somewhere about 20 gigawatt of storage so far, which is far lower compared to what is required and what kind of solar energy we are also talking about. So we have a big, I would say, big distance to cover as far as both HVDC as well as the storage battery is concerned. Fiber network as part of the communication is extensively used. So I would say the implementation is quite decent as far as these are. So Megha, these are some of the technological trends. I don't want to get into too much of technical discussions on this, but I only wanted to touch upon some of the trends in the smart grid, what are all is implemented already and what needs to be implemented in the next. Coming back, the second part of the problem, reality check. So the reality check actually talks, to me, then how much have we done? We talked about smart grid. Where are we as far as India's overall smart grid implementation is concerned? So it is very, though it has started off almost, it is now a decade that we have been talking about smart grid. So unfortunately, not much is done as far as implementation is concerned. So these are the details from the government side itself that I have taken. So some of the initiatives were started way back in 2015, 2016, and 14 projects were taken as a pilots study. Some of them were implemented in Assam, in Mysore, in Haryana. These 3-4 states have reached some advanced stage of implementation, but these were the things that they have identified, and various programs has been derived. Like there are schemes under the IPDS where the smart meter implementation and the entire smart grid implementation was done, and there were also program from the utility side which was driven. So both central as well as state utilities were involved in terms of driving this program, but it has not taken much, I would say, the pace as it should have been. So today it's a very at a very nascent stage. I can say, yes, in pockets we have implemented, but my idea of smart grid is an end-to-end connectivity that I talked about. Unless until every user is connected and then the demand supply management is done through those systems that I talked about, the complete benefit of the smart grid cannot be really seen. So these are some of the national initiatives that I talked about right from 2000. That's what I said. It's more than a decade now that we have been talking about. They talked about the ISGTF force, then he reconstituted again as an SGM in the 2015. And then some expert panel also has been put. So these are some of the things that I just thought I should take it up. Yeah, these are again the renewable initiatives, battery energy storage initiatives, energy corridors that I talked about, WAM that I talked about, wide area monitoring protection system. Some of the systems have been implemented. These are all the government initiatives, but I will not stress upon these things because these are these are not really progressed well to an extent what it should have been. So hence I'm coming to the challenges. So the biggest issue of we having everything smart, it also comes with the precaution and also kind of a warning bell, cyber security. Now there were discussions that in Mumbai also there was a blackout. In some other area there was a big blackout. There has been a discussion of cyber security being hacked. We don't know whether actually that was the case or not, but it is quite possible that because the more and more it is IT driven, the more and more these are digital, then there is a vulnerability of the hacking of the system, and then the cyber security is in question mark. So hence, privacy, to maintain a data privacy, to maintain protection, government also should come up with a very, very different level of protection that becomes a need of the hour. Why this is still maybe not to an extent implemented, it also requires huge capital. It also requires huge operating costs. Though the benefits are immense, but initial capex requirement is also very high. So today the power sector is reeling with so many other issues. Discoms are financially bleeding. There are basic issues to be addressed. So definitely the priority definitely will be maybe a problem for a government also to take and infuse money and capex into these initiatives in a big way. Maturity of the technology is another challenge because I talked about those trends and other things. Those are also requires certain stability, certain performance levels. Though in Western countries, in some countries it is proven, but it is not widely used, and hence maturity of a technology is also a question mark, which requires some time period. Awareness is what we still don't have. As I said, many people think smart grid is only an automation or a manless substation, which may not be. Then it is also in a way, it is more of a management than a solution. Because I'm talking about data management, I'm talking about demand supply through a data, I'm talking about data, transmission, through a sensors. So may not be a hardcore solution, but it's more of the arrangement and the two-way communication that I talked about. So these are some of my initial thoughts, Megha, as far as the subject matter is concerned. Thank you.